Okay, so welcome back. This episode is gonna be about stairs and doors. We want to be able to traverse through doors as though they were just like, you know, there's nothing there in the way. At least for pathfinding purposes anyway. And then for the stairs, we want to be able to have some connections, you know, from the lower stair to the upper stair, and from the upper stair to the lower stair, and to some floors above. What you're looking at right now is a battlescape with the west walls removed, just so we can see what's going on. If I move my cursor here, you can see all the walls, the north walls are blocking the cursor. There's only 5 neighbors. If I move it here, there's 6 neighbors, and you can see behind the door, you know, that node connected. And if I move to the, you know, that node, then the node in front of the door is connected. So that's what we want. This works for west walls as well, west doors. And for stairs, this is the lowest stair. It might be a bit hard to make out, but it's connected to all of the nodes around it, apart from the ones on this side, because there's a wall in the way. So it's connected to this one, and this one, as well as this one. And it's also connected to the upper stair as well. And the upper stair, as you can see, is connected to the lower stair. And it's also connected to 3 nodes above it as well. So this upper stair is on level 0, and the nodes it's connected to on the upper floor on level 1 are the 3 you can see there. Let me just switch my camera so I can kind of explain using that diagram that I've been using a lot. So here we go. So here is the upper node, and on level 1 it connects to number 7, and then on level 1 it connects to these 3. And while I've been recording, I'm thinking, okay, well, we're not accounting for if there's a wall here, but it's not a big deal right now. You know, we can take care of that when the time comes. Anyway, hopefully that explains what we are trying to achieve, and then how we're going to do it. If I close this battlescape, and then we're looking at the city decoration sprite, and luckily I had enough foresight to organize the sprite so that all the stairs were near the beginning. And then the reason for this is because we're going to have arrays. So on the right, you see we have 4 tile parts for every biome. We have a floor, west wall, north wall decoration. We're going to have an array of arrays, and we're going to have 12 arrays stored in one big one. It's going to be like a 2D array basically. And say for example we are filling the array for the city west wall. For as many images that are in the sprite, there's going to be an entry in the array, and when we initialize the array, we're just going to set every entry to 0. But then we're going to say, okay, if there is a door, then set it to 1. We also have a second entry to say whether the door is open. So 0 is no door, 1 is a door closed, and 2 is door open. But that's just kind of trying to future-proof our code from when we can open and close doors. It's not going to have any effects right now. All we're interested in is whether the entry in the array is a 0 or not. If it's a 0, then it's a wall like this. If it's a 1 or 2, it's a door. And basically we can say, okay, well, just pretend there's no wall there because we want to path through it. That's what we're going to be doing. Let's just get into the code now. So if we go into the create event of OBJ Battlescape, so ignore this for now. That's for a bit later on. So we've got 2 new enumerators. We've got stair type, none lower upper, and door type, none closed open. This region is going to initialize our arrays that I was just talking about. This is what's going to set the zeros. You can read this if you want. So this double for loop is creating those arrays that I was talking about. This is our array of arrays, or a 2D array. You know, that's what it is basically. And we go through every biome one by one. And for every biome, we go through the 4 tile parts, and we get the sprite for that tile part. And then we check how many images are in that sprite, because they're all different. And then we just say, okay, for that biome and that tile part, create an array as big as however many images there are. Whenever you make an array, if you don't give it any data, each entry is going to start as 0. That's if you're using this function. If you use this function, every entry gets a 0 by default. There is other ways to make arrays. Not all of them end up with you having a 0 as an entry, so just bear that in mind. So after this double for loop, we now have a 2D array full of lots of zeros, and now we are going to update it to tell the array this is a door, this is, you know, a lower or upper stair, etc, etc. You can see here for the barn, the second image is a lower and the third image is an upper. And if I go into the barn deco sprite, you can see what I'm talking about. So this is 0, this is the second image index, or 1, and it's a lower stair. This is the third image, or number 2, and this is the upper stair. So that's what we're talking about when we say 1 and 2 is a lower and upper. And for the city, 1 and 3 are lowers, and 2 and 4 are uppers. So that takes care of the stairs. And then for the walls, for the barn, the second image for wall west is a closed door, and the same for the north. The way that I organize the sprites is the west wall and north wall should all be, the sprites should all be in the same order to make this kind of stuff easier. And then because there's 4 entries in the city for the west wall and north wall that are doors, I just did a for loop. So if you have 10 doors, just do this. Organize your sprites so you can just use a for loop. It saves you a lot of typing. And that's it for the initialization. Okay, so let's go into the step event of the Battlescape object, and we're gonna update our code for the nodes now. So in the create node structs region, we want to be in task 2 of this triple for loop, and yeah, so right after we check to see if there is actually some data, because if there's no data, none of this really applies. So just after we create the nodes to delete array, we're going to get the actual image index for the west wall for this list. So if it's image index 10, it's going to return a 10. Then we're going to use this information to track in our new array that we just made. So is this actually a door, or is it not a door? So door value W is either going to be a 0 for walls, or a 1 for closed doors. It should never equal a 2 right now, because we haven't set anything to 2, which is open door. So that's what this should equal, a 0 or a 1. And we do the same for north walls as well. We end up with this variable, which is 0 or a 1. And then we're just going to update our line here. So if there is a west wall and the door value for the west wall is not a door, so this has been added, as long as these 2 conditions are true, then we're gonna make this wall stop adjacent node connecting to it. But if it's a door, then this is going to get ignored. And then when we scroll down, we're doing exactly the same thing here. So is there a north wall? And it's not a door. So it has to have 2 conditions. So this has been added. And then we have decoration. I think I made this into a region. I don't think we had it as a region before. I can't remember. But anyway, we want to get the deco index. So which image index is it? And we're going to get the stair value from our new array. Okay, so with stair value, we're going to be using it in the same way we have for the west and north door values, but it's going to be a little bit different because we want the lowest stair to still connect to every adjacent node unless there's, you know, decoration or a wall in the way. So we still want that, but for upper stairs, we don't want to connect to any adjacent node apart from the lower stair. So that's why we're not checking for that here, because we're still going to remove every adjacent node from upper stairs. And then I've just added this little region here for the upper stair. So for the upper stair, we are going to remove the node which is the lowest stair. We're going to remove it from the nodes to delete array. So we're going to stop it being removed. It's being added here and we're removing it here. That was like the simplest way I could think of doing it without changing too much. And then, like I said, we're going to add the 0, 1 and 2 entries from the floor above for the upper stair. We have a check to make sure we're not at the max level, because if we are, we're going to get a crash because there is no floor above. Hopefully we don't have any maps where, you know, the upper stair is on the highest floor we can get, because that wouldn't make sense really, unless you're making some kind of weird maps. So as long as there is a floor above, then we're going to grab the upper node, which is the node directly above the one where the upper stair is. We're going to make an array. And we're going to add 0, 1 and 2 to it. This is another way to make an array. Why 0, 1 and 2? Because those are the entries that we want to add to our nodes array. And like I said here, what I'm doing in these lines is probably what we should have done when we added nodes in the first place. Just had a couple of scripts, you know, where we pass entries in an array and we tell it what array to add it to, but I didn't do that for this episode, so probably in the future I'll update the code for that. This is how I tend to do code, by the way. I tend to do it like in a bad way, and then I'll find ways where I can, okay, you know, this would be a good way to make it into a script, because I recognize the consistencies between different things and how I can make it into a script, and then that's when I do it. So apologies for that. So anyway, for as many entries in nodes to add that we have, we want to first grab the node. I'm thinking now what we should do as well actually is say if node to add is not equal to -1, because it could be. Yeah, there we go. So get which node is in the position 0, 1 and 2. If it's not -1, then it's a proper node. Check to see if that node is not already in nodes walk for the upper stair. If it's not already in there, then add it to the array. There we go. That's the upper stair region. Okay, so let's go further down. I think that's everything for the create event. Sorry, for the create state. That's everything. So what we've done is we have made doors no longer block movement. We've made lower stairs no longer be disconnected from adjacent nodes on the same level, and we've made the upper stair connect to nodes above it as well as the lower stair. That's what we've done so far. So now that we've done that, we actually want to be able to see it visually. So what I did is I went into the create event of OBJ Battlescape. So minimize this new array, and I added a new variable called show roof, and set it to true. You can have it to false. I think I did that to begin with. So let's set it to false. And then in the draw event of the Battlescape object, I have these lines here. So if we're showing roof, then the level what we want to draw up to is going to be the size of the Battlescape -1. So we're going to be including the end level in our drawing this time. Otherwise, if show roof is false, we're going to say end level is the same as current level, and we've included end level here in our for loop, and we're using as opposed to less than, we're using less than or equal to make sure that we include the end level. I also updated the draw Y to the same as our map editor, so it just removes the gap between the floors that we have. And then this line here, I updated it just so that the west walls weren't being drawn. So this code that I've highlighted is what I added, and this stops the west walls being drawn. And that's it. So if we run the game, we should be able to test everything now. So we are not showing roofs, and hopefully you can see that the doors are no longer stopping movements. So this node I'm on right now doesn't connect to this node, and it doesn't connect to this node because the walls are in the way, but it does connect to through the door. And there's a gate there. You can't see it because it's on the west wall, but you can see, you know, that's also connected, vice versa. And then for the stairs, so this lower stair is connected to 5 neighbors. So this one, this one, this one, this one, and the upper stair. And then the upper stair for level 1, sorry, for this first level, the bottom level, it's only connected to the lower stair. And then if I think I have to change this variable show roof to true, and then run the game again to be able to see the upper floor. So you can see for the upper stair, it's connected to the lower stair as well as 3 nodes above. I think I said that we're not accounting for whether there's walls in the way. There could be a west wall that's blocking 2 of those nodes. Yeah, obviously, actually, we can see there's a problem already because let's just do ourselves a favor. Okay, let's go back into the step event, because I don't like the fact that you can, you know, the upper stair connects to the outside through a wall. Let's just change that. So so we're in upper stair, and we're actually only going to add 1 to it. So we're just going to add 1, and the code will work the same. Let's run the game again. So now the upper stair connects to the node above it, and then yy-1 to this one. So this node basically, and then to the lower stair. So that's working better. I think I prefer that. And it seems a bit silly for the player to be able to go from here to these 2 nodes anyway, regardless of walls. So that's going to do it for this episode. Hopefully you enjoyed it. I will catch you next time. Bye for now.